Okay, so in this video, we're going to talk about parallel circuits. We've already previously talked about series circuits. Remember, the series circuit, there's only one path for the electricity to flow, but in a parallel circuit, the path divides, and that creates more than one path for the current to flow. Each path is called a branch, and the point where the branch occurs is called the branch point. So if we look at this picture below, we would call this branch 1. This could be branch 2. And this would be branch 3. And so this is a parallel circuit with 3 branches, 3 paths for the electricity to flow. Also has 3 resistors, right? 1 resistor, 2 resistor, 3 resistors. So in this, the electricity would flow from the battery through the resistor and back in path 1. Path 2 it could take, and path 3 it could take. So a parallel circuit is parallel because it has multiple paths for the current to flow. To calculate current in a parallel circuit, you would use this equation here. This says that the current at this specific resistor or this specific branch is equal to the voltage at that same branch divided by the resistance at that same branch. So this N here just stands for the number that is the branch number. The amount of current flowing into each branch has to equal the current flowing out of each branch. This is called Kirchhoffs Law, and basically it says that the total current of this system is equal to the current at branch 1 plus the current at branch 2 plus the current at branch 3. So if I wanted to find the total current in this system, I would have to calculate the current here at branch 1, here at branch 2, here at branch 3, and then I would need to add them all up. Of course, this diagram doesn't have any numbers, so we can't do that here, but we'll do that on a slide that is coming up in just a minute. All right, let's talk about voltage. So the voltage across each branch of a parallel circuit is the same. Yay! That makes it super easy, right? Because whatever the total voltage is, it's the same for every branch of a parallel circuit. Each branch has its own special connection to the battery, so each branch receives all of the volts. So if you start with the 6-volt battery, branch 1 gets 6 volts, branch 2 gets 6 volts, branch 3 gets 6 volts. That's why when you have things that are wired in series, all the bulbs can shine with the same brightness. So parallel circuits are kind of like several series circuits connected to the same battery. So if you just put a bunch of series circuits to the same battery, that would act like a parallel circuit. Each branch starts with the battery voltage, like I said, however much it has, 6 volts, 9 volts, whatever, and it ends with 0 voltage. So all of the voltage is going to be used up along the path in the circuit, and when it goes back to the battery, 0 volts are left. Resistance in parallel circuits is kind of weird. It's different than series circuits because when you add up all the total resistance, it's actually going to be less than each individual resistor, which sounds kind of counterintuitive. In a series circuit, when you add them all up, you get a big total, right? But in a parallel circuit, the more resistors you have, the less total resistance there is. And this is the equation that we would use to calculate that. Actually, we've got it rearranged in 3 different ways because it's kind of a little bit tricky. So you have 1 over the total resistance is equal to 1 over the resistance at branch 1 plus 1 over the resistance at branch 2 plus 1 over the resistance at branch 3. If you use this calculation, you have to remember at the end to take the inverse in order to get the total resistance. So personally, I don't like that equation. My favorite one is this, which basically you can just do 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3. You get a number, and then you do 1 divided by that number. But a lot of my students like to use this one because you can put it all in the calculator fairly simply, and then just press enter at the end. Make sure you have these parentheses here. So you do 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3, and then you take all of that to the negative 1, which is the same as what we said here to take the inverse. And this is what it means by inverse, right? You do 1 divided by that number. So really these are all the same, and you can use whichever one you choose. But when you get to the end, make sure that your total resistance is smaller than each of your individual resistors, just to check your work. So if your total resistance at the end is 1, then all of your resistors have to be a number greater than 1, like 5, 3, 2, something like that. Okay, so now we get to practice. This says to find the total current and the total resistance of this circuit. So, this might take a little bit of time to find the total current here, but let's see what we can do. We can do the total current, that's IT, is equal to the current at number 1 plus the current at number 2 plus the current at number 3. Now, we have to go back and find the current at each of these places. So remember our equation here was the current at N resistor is equal to the voltage at that resistor divided by the resistance at that resistor. So let's go back and do this for all of our different resistors. So we have I1, and then let's look here to find our voltage at 1. Remember, because this is a parallel circuit, the voltage is going to be the same at each branch. So that means you're going to have 6 volts divided by the resistance at resistor 1. So that's 6 divided by 1 equals 6. And the unit for current is A for amperes. So that's 6. All right, let's try the current at resistor 2. So again, same voltage, so that's going to be 6 divided by the resistance at 2, which is 3. 6 divided by 3 is 2 amperes. All right, and then the last one, I'm just going to go up here because I'm trying to save some space for calculating the total resistance. All right, it's going to be the current at 3 is equal to the voltage, 6, divided by the resistance at 3, which is 2 ohms. And so 6 divided by 2 is 3 amperes. All right, so now I have 2 plus 6 plus 3, right? So this was 6 plus 2 plus 3. So that's 6 plus 5. And your total current is going to be 11 amperes. Ooh. All right, so a little bit of work to find your total current there. Now, let's go back and remember the calculation for total resistance. I may have to grab my calculator here. All right, so total resistance, and I'm going to do that last equation there, is 1 over R1 plus 1 over R2 plus 1 over R3. If we had more resistors, we would also add them in there, right? And I'm going to take all of that to the -1. So give me a second because I forgot to grab my calculator, and then we'll get that taken care of. Just a second. Okay, now I got my calculator ready. Let's plug in some actual numbers here. So that's going to be 1 over, don't forget my parentheses there. That's a really bad parentheses, but sorry guys. All right, so resistor 1 was 1 ohm of resistance, right? So resistor 2, so that's going to be 1 over resistor 2, which is 3 ohms. And then resistor 3 was 2 ohms of resistance. So that's going to be 1 over 2. And in my parentheses, I'm going to take all that to the -1. Let's see what our total resistance is here on the calculator. And then we'll check to see if it makes sense. Okay. All right, and for my resistance total, I got 0.5454545. I'm going to round that to 0.55. Make sure you can see that decimal there. Ohms. Now, remember conceptually what we said about total resistance is that your total resistance has to be less than each of your resistors. So our first resistor was 1, it's less. 3, it's less. 2, it's less. See, the total resistance should be a smaller number than any of the resistors you have on your parallel circuit. Okay, so that's the end of our math problem for today. And then we have one more slide here on your notes that's basically just telling you about an instrument that we use to measure current, voltage, and resistance. So current can be measured with an ammeter, and basically you let the current flow through it and it can tell you how much or how big the flow is. Voltage is measured with a voltmeter, so you put 2 probes on either side of the thing that's being measured and it will tell you the voltage. And then resistance can be measured by an ohm meter, and it basically is the same as that. You just touch 2 ends to the resistor and it tells you what the resistance is. Now in class usually we use this thing called a multimeter, and a multimeter looks kind of like this. It has built in an ammeter, a voltmeter, and an ohm meter, and you just flip this little dial around to measure what you want to measure and the maximums for what it can measure. And then you just use these 2 little probes right here, the black probe and the red probe. You touch it to the source of whatever you're trying to measure. Voila, magic, your answer comes up here on the little screen. And this is the end of our discussion of parallel circuits. So good luck.